Hi everyone, in this video we're going to walk through how to enter the BTU factors for heating on the whole house heat loss and gain worksheet. This step takes the construction values, so the area of the net walls, ceiling, floor, so the area, so that these construction values, and we're going to look at our building and find out what kind of material is behind that wall, or inside the wall I should say, and behind the ceilings, and what kind of floor we have. Either a visual inspection by walking around the building and observing, we'll know what kind of construction material we'll have, and then we'll place depending on that BTU value. And the BTU factor is simply the BTU content that heat will travel through this material. So we just can't say that BTU travels through walls at 0.3 BTUs per square foot. We have to know what material is inside of the walls. So how much insulation, how much fiberglass, the ceilings, how much insulation is above the ceiling. We're gonna have to figure that out in this one. And the floors. So in this example, if you go in the back of your worksheet, it gives a list of most of the values concerning the material that we're working with. So in the example that we're doing tonight, we are going to be using for walls, no insulation in the walls. And if you follow this row, or the pretend row here, you'll notice that for no insulation in the walls, the BTU factor is 0.30. So this is where we're getting our information from, is on the back of the chart. No insulation in the walls. What about the ceilings? Well, for this example, we're using no insulation in the ceiling, above the ceiling, 0.70 for that heat factor. And for floors, we're going to go with the concrete slab, meaning the floor is made out of concrete. It's unheated. There's no heating taking place in the floors. And if you'll notice it in the abbreviations right here, it says BTUs per foot or perimeter. So what we're going to do is, instead of using the area of the floors, we're going to use a perimeter, and then we'll multiply it by the it says no edge insulation, so there's no insulation on the edge of the concrete. And so our heat transfer rate on the concrete edge is going to be 0.8. That's where we're getting our numbers. So what kind of house doesn't have insulation in the walls or attic? Well, a lot of homes before the 1980s and early 70s, most of the homes, this is back in the day, of course, a lot of you guys probably weren't born, but in the 70s, 60s, and even older, the homes really weren't required to have insulation. There wasn't really an energy standard for homes to have insulation in the attic, the walls, or the border of the concrete floors. So here's where we put in that number for heating. So our walls, we put no insulation. That's where we get the 0.3 in the back of the chart. And for ceilings, we're using 0.7 for no insulation in the ceiling, above the ceiling wall, or above you. And then the floors, we're using 0.8, and we're only going to use the perimeter. So we'll have to figure that out when we get to this part. Now that we have our BTU heating factors in for our material, really they're just three areas: walls, ceiling, and floor. So we just had to pull 3 points from the back of the worksheet. So the goal of the heating section is to calculate the BTUH heating loss. And so everything in gray we don't really have to worry about. It's grayed out for a reason. It's not necessary to put any information in these boxes here. But we will have to start putting the BTU loss from table A, because table A is our heating loss chart for windows and doors. So this is our square footage, an area from this construction of the building. But just the BTUs, which is this column here, this first box right here, we are going to enter, if you look up to the top, you can see 139.5 BTUs. So we'll enter 139.5 BTUs of loss through the windows and doors. And we got this number from our table A, heating, windows, and doors. How do we calculate the wall BTU loss? Well, the heating factor gives us the amount of BTUs we're losing for every square foot. So we're going to multiply 1243 times 0.3, and that's going to go over here in the BTUH loss for net walls. So 1243 times 0.3 gives us 372.9. We're going to round that to 373. Let's go ahead and round this one to 340. Next, we're going to multiply the ceiling, 1,280 square feet times 0.7. Again, this is no insulation above the ceiling. So 1,280 times 0.7 gives us 896 BTUs of loss. 896 BTUs. As you can see, it's just simple multiplication. So we're going to do the same thing for the floors. Oh, you know what though? I remember that we picked concrete, so we're only losing heat on the perimeter. If we had an elevated floor, wooden floors, then we would use the floor area because that whole bottom floor would be affected by heat loss. But since we are just using concrete, it calls out basically just to use the perimeter of that building. How do we get the perimeter of that building? Well, you go back to your plans. Let's see here. Go back to your plans and you add up all the sides of the building. So one length of this building is 40 feet. The other length is 32 feet. And this is a pretty simple shape building. 40 feet of length on this side of the wall building. And we're going to have 32 feet of length on this side. And you have to add up all the sides of the building to get perimeter. So we're going to add up 40 feet twice because there's 40 feet on this side and 40 feet on this side. We're going to add 32 feet twice because there's 32 feet on this side and 32 feet on this side. So when we add up all the sides of the building, that's going to give us perimeter. Let's do that now. Over here, we're going to change this to perimeter. So P equals, so 40 plus 40 is 80. So 80 plus 32 is 64. That's 144 feet in length of that building. And so it's 144 times 0.8. And our total BTU loss that we're losing through the perimeter of that flooring is 115 BTUs. Next, we're going to add up all these numbers. So that's going to be our sensible total loss. So we're going to add up 140, 373, 896, and 115. We'll do that now. So go ahead and 140 plus 337 plus 896 plus 115. And my total is 1524 of BTU loss so far. Okay, the next step is, if you'll notice this little note here, number one, it says number one, so let's find the note. It says multiply heating design temperature difference. So we work this at the very top of the worksheet under design conditions by the total heat loss shown in the sensible table. So I'm going to refer back to an old slide. We did cover this in design conditions too. And our numbers that we got for Kern County for the heating or the winter inside design temperature of 70-degree target temperature, we're shooting for 70 degrees inside our building, minus the outside design temperature, and we pull that up from the ASHRAE weather stations of 36 degrees. So 70 minus 36 gives you a heating temperature difference of 34 degrees. So this is going to be our temperature difference that we're going to use to multiply our heat loss in BTUs. So our sensible total heat loss of 1524 times 34 degree temperature difference equals And this is kind of where you see that the BTUs that we're losing and how the number increased depending on the temperature difference. 51,816. And so far, that's our heat that we're losing through the building. But wait a minute, we have a duct loss multiplier. We're not using the gain. This is a either or. So we'll be using this multiplier for the cooling season. But for winter, we're losing heat. So here's our multiplier for the heat loss in our attic or our unconditioned space. So now we got to times this 51,816 by 1.15. And that gives us 59,584. Oh, sorry, 588. So 59,588. So this is our total BTUH loss for heating season in our building. So we added up the windows and doors, the net walls, the ceilings, the floors. We added that all up. Then we multiplied this BTUs that we're losing through those areas by the temperature difference. And every time you have a temperature difference, it increases heat transfer. And look at how it increased it. Increases 1,524 BTUs per hour by 51,816 BTUs per hour. And we can't forget our ducts in the attic. We multiply 1.15, and now we're at a total heating BTU loss of roughly 60,000 BTUs. So if we were going to size a heater for this house, this particular house, and how it was designed, we would size a 60,000 BTU heater or furnace to put back heat into the building, because this is how much heat we're losing from the building in the wintertime at those design conditions. So to keep up with that heat loss or the BTUH loss an hour, we're going to have to size that house or the unit for a 60,000 BTU furnace. So to summarize, you pull the points, the U factors or the BTU factors, from the back of the worksheet on the other side of the paper, depending on the material that you're pulling or using for that house. There's basically just 3 points. You pull the windows and doors information from the table A chart up at the top left of the paper, and you multiply each section, and that'll give you your sensible heat for your walls, ceilings, and floors. You add all these up. You multiply your sensible total by your temperature difference in your design condition section. You multiply your subtotal by your duct loss, which is 1.15, and that gives you a total of 60,000 BTUs in this particular case. Guys, if you have any questions, email me, text me, ask me in class. Hopefully this simplified the heating section. I'll be covering the cooling section in another video. You guys have a good night. See you later.